Welcome to Study Loop.
Okay, so we have CH3, CH2, CH3. That is butane, right? And what we need to draw is 6 conformers of butane as well as their energy profile. So the simplest way to do this will be to draw a Newman projection in which we look down bonds 1 and 2. Right. So I'm going to make this front carbon green, and carbon 2 in the back I'm going to make blue. Right. So what we're talking about then is green in the front, and we'll start with hydrogen, 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 right? And the back is our blue carbon. Okay. And as we know, the substituents we have on carbon 2 would be hydrogen, hydrogen, and a methyl group, right? On 1, we just had 3 hydrogens. Here we've got hydrogen, hydrogen, methyl. And let's start with them staggered. Okay. And so then what we'll do each time is rotate the back carbons 30 degrees, right? And if we do this 60 degrees. And if we do this 6 times, we'll be back to our original structure, right? 6 times 60 degrees is 360. So green carbon in the front. Hydrogen, hydrogen, hydrogen. Blue carbon in the back. And we've rotated. We're going to do clockwise, 60 degrees. Right, so now our methyl will be overlapping or eclipsing with our hydrogen. This hydrogen will be eclipsing, and this hydrogen will be eclipsing. Right, let's do that again. Rotate another 30 degrees. We leave the front the same. Draw our blue carbon in the back. Rotate 30 degrees, so now we'll be staggered again. Methyl will be here. Hydrogen and hydrogen. Okay, now we'll do clockwise another 30 degrees. Green in the middle. We're going to leave the front the same in each case. Hydrogen, hydrogen, hydrogen. Blue in the back. Now methyl is eclipsing the top hydrogen, hydrogen, and hydrogen. Another 60 degree rotation. Blue in the back. Hydrogen, hydrogen, hydrogen. And in the back, now the methyl is once again staggered. As are the hydrogens. And final one. Oops. And then these need to be eclipsing. There we go. Now notice that in each case we have 6 staggered with a methyl next to 2 hydrogens. Right? And every other structure has that exact same layout. 6 staggered components with a methyl between 2 hydrogens. And for the eclipsing structures, we have a methyl eclipsing a hydrogen and 2 pairs of hydrogens eclipsing each other, right? Methyl hydrogen, 2 pairs of hydrogen. Methyl hydrogen, 2 pairs of hydrogen. So in terms of energy, these are basically indistinguishable from each other. That is, these 3, which I'll label A. Well, actually, let's label them S for staggered, 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 are indistinguishable from the E for eclipsing varieties, right? So in terms of an energy profile, we're really only going to have 2 energy levels, staggered and eclipsed, right? So let me define these here as 0 degrees, 60 degrees, 120 degrees, 180 degrees, 240 degrees, and 300 degrees, so that when we make our energy profile, we'll have a reference. At 0, 60, 120, 180, 240, 300, and then we've got the low energy and the high energy, right? Low is for the staggered and high is for the eclipsed. So then we just expect a sort of and if we wanted, we could go to 360, which would be equivalent to going back to 0, right? 360 degrees around gets you right back to where you started.